All right, Mr. Ahmed here for calculating the standard deviation. So the standard deviation is a measure of how the values in a data set vary or deviate from the mean. So we want to see how far they are away from the average. In order for us to calculate the standard deviation, this is the actual formula, which in itself looks very, very complicated. We have a bunch of Greek letters that we haven't seen. We have x bar. So we're kind of going to break this down into making a chart for this process in order for us to calculate it. When we work on this, you will be allowed to use this sheet on your quiz and any form of homework that we'll be working on. This isn't something you're expected to have memorized. So the standard deviation formula, we have the Greek letter sigma, which kind of looks like an O with a little tail on it, and that represents the standard deviation. So we're going to calculate the standard deviation. It is equal to the square root of the capital letter sigma, which represents the sum of a series of numbers. And then we're going to multiply that by x minus x bar. X stands for a value in the data set. X bar is the mean of the data set. And n is the number of values in the data set. So the first step that we will have to follow is we'll have to calculate the mean. So this chart's filled in. I'm going to kind of step through how we would calculate it on this one, and then we'll do a blank one as well. So for us to calculate the mean, I have 1, 2, 3, 4, 5 values. These x's, that is each value in our data set. So I need to add all of them up, which is 12.6 plus 15.1 plus 11.2 plus 17.9 plus 18.2 and press enter. And then I divide it by 5 because there are 5 of them, and we would get the mean x bar to be 15. So we're going to put 15 in for all the x bars. We then calculate x minus x bar. So I have to take 12.6 minus 15. So when I get 12.6 minus 15, that gets me negative 2.4. So I'm taking x minus x bar. X minus the mean. And then I would do that for all of them. So then I'd have to do 15.1 minus 15, which is 0.1. Then I would have to do 11.2 minus 15, which is negative 3.8. Then 17.9 minus 15, which is 2.9, etc. After I calculate all of those, I have calculated x minus x bar. So I'd have to take that value, negative 2.4, and square it, and I would get 5.76. Then I would have to do 0.1 squared, and I get 0.01. This should always end up being a positive value after you square it because the negative would be inside the parentheses. So then I would take negative 3.8 and square it, 14.44, etc. Now for us to calculate here, we have to find the average of x minus x bar squared. So I have to take all of these and add them up, which I will complete here. So I'm taking 5.76 plus 0.01 plus 14.44 plus 8.41 plus 10.24, and then I'm dividing it by 5. All right, so that's how I'm finding these. I'm adding up all these values and then dividing by how many there are. So we'll do that here real quickly. 5.76 plus 0.01 plus 14.44 plus 8.41 plus 10.24, and then I divide by 5 and we get 7.772. And then finally, to calculate the standard deviation, we take the square root of that. So we take the square root of 7.772 and we get 2.79 for the standard deviation. So that is the process we need to follow. So we're going to do that again here with a blank chart to calculate the standard deviation. So first step, we have to find the mean. So 13.4 plus 11.7 plus 18.3 plus 14.8 plus 14.3. And I get 72.5 divided by 1, 2, 3, 4, 5. There are 5 of them. We get 14.5. Okay, now I have to take x minus x bar. So 13.4 minus 14.8 14.5. And we get negative 1.1. And then I would square that value to fill in x minus x bar squared. So I'm going to do that in one step since I already have it calculated. Just press my squared button. And I get 1.21. Now I repeat the process. 11.7 minus 14.5 is negative 2.8. Square it. 7.84. Now 18.3 minus 14.5, which is 3.8. Square it. 14.44. Now 14.8 minus 14.5 is 0.3 squared, 0.09. And lastly, 14.3 minus 14.5 is negative 0.2 squared, 0.04. Now I have to add them all up, divide by 5. So that's my next step. 1.21 plus 7.84 plus 14.44 plus 0.09 plus 0.04. Enter. So this is 23.62 divided by 5. 4.724. Take the square root of that. And we get 2.17 for the standard deviation. So after I took the square root, 2.17. So now we're going to answer a couple questions. Which data set had a greater standard deviation? So the greater standard deviation was data set 1. And the data set with the larger standard deviation has a larger, more spread out range of data. Okay, so it's a little bit more spread out. If many of the data values are close to the mean, then the data would have a relatively small standard deviation. This would tell you that the data is not very spread out. So this is just a calculation that really tells us how close we are to the mean. All right, that's it for today. Have a good one.